Right, in this video we're going to use some GeoGebra applets to come up with these graphs, and I'm going to put the links to both of the GeoGebra applets in the notes of the video for you to actually try this out. So it says on the same axis sketch the graphs of y is equal to f of x, y is equal to 2f of x, and y is equal to f of a half x, where a, f of x is x cubed, and b, f of x is 1 over x. So let's go to our GeoGebra app. So here I have a basic graph of f of x is equal to x cubed. If I click the red one here, I get a f of x, where in the first case a is 1, so it's just the same as y is equal to x cubed. So I'm going to sketch, this is a stretch of a units in the x direction. So if I make a 2, like in the question, you can fine tune it with the arrow, then we can see what has happened here. What this does, okay, if we take that point there, okay, on the new graph it's now 2 units. So what happens now, this graph has been pulled upwards 2 units this way and downwards 2 units this way. So this is called a vertical stretch, or stretch of a units in the x direction, or stretch of 2 units, because a is 2. For example, if I was to make a 4, which I can do with this, fine tune it. Okay, so for example, this point is 1, 1. Now it moves to 1, 4. So the y coordinate changes by 4. So you need to multiply the y coordinates by 4. That's what you do in this type of thing when the letter is in front of the function. Okay. Right, so I'm just going to unclick that one, put this back on 1. To now do f of brackets ax and see what that does. Okay, so if I make this a half, which is what I'm asked to do, which is there. Okay, what happens this time? This is a stretch, it stretches the x coordinate by 2 units. So this is a half here, it's a stretch of 2 units here, 1 over 2. So you multiply the x coordinates by 2 units, and you see the same happening here as well. If I was to make it so that a is a quarter, which I can do, which is there. Okay, what I can see now is this is 1, and then now that point goes to 4. And this is what happens if you've got a f of ax, then it is a stretch of 1 over a unit in the x direction. So if this is like a quarter, okay, so it's 1 over 1 quarter, so it's going to be a stretch of 4 units in the x direction as I've got it at the moment. We were asked to do 0.5. Sorry, we were asked to do half, sorry, that one there. Okay, so we can see everything, and we can see it here as well. This distance here is half of that distance. Okay, so what happens is it is pulled 2 units in horizontally, so you need to multiply all the x coordinates by 1 over a, so 1 over by 2 in this case. Okay, so going back to this, these are the relevant graphs. Okay, so this is the first one we looked at, this is the second one. So in the first case you've got y is equal to 2f of x, so that's going to be 2 times x, f of x is x cubed. Okay, so it could just be 2 times x cubed. Okay, and in this case it's going to be y is equal to f of 1/2 of x, so y is going to be 1/2, so what we put is 1/2 of x, 1/2 of x all cubed. 1/2 cubed is 1/8, so it becomes 1/8 of x cubed. So therefore we'll see this one will be much shallower than that one. So it's important that you get this idea round the right way. A in front is a stretch this way, a in the bracket is a stretch this way, but 1 over a is the stretch factor. Okay, so if it's a half, it's going to be 1 over 1/2, which is going to be twice the distance. Okay, we're now going to look at for f of 1 over x. So in this applet we've got the graph of 1 over f of 1 over x, which is this one here, and this one here. We should know this graph by now. If I click here, I will get y is equal to a f of x, and it's set at 1, so it will be the same as this one. So if I now make it 2, it becomes that. Okay, same sort of thing happens if we look at this point here. This distance is now 1, and now the y coordinate will become 2 if we put 2 in front. If I make a 4, like I do there, here it is 1, and now it is 4, and the same down here as well. This is down 1, now it will go down 4. Okay, so you multiply the y coordinates by 4, sorry, it's at 4 now. Okay, so let's put this now back at 1 again to consider the other function. Let's unclick this one and now click this one, so it's now on the same place. We've got y is equal to f of 1x, okay, and I had to make a half, and something interesting happens here. There's a is equal to half, okay, and instead of going this way this time, it's now stretched this way, so this is now 1, and it will now become 2. So the x coordinates are all multiplied by 2. However, we might notice it's actually the same graph. If I make this 0.25, which I can do, okay, this is now 1 this way, and if I pull it this way, it's now going to be 4. Okay, and the same down here, this is minus 1 this way, it will now become minus 4 if I multiply the x coordinates by 4. Okay, so we notice actually we get the same sort of graphs as we do in the first one. It doesn't matter which way around. If I click them both, it will be the same graph. Okay, so let's just go back to this. There's a screenshot of it. Now let's see why they're the same graph. So we've got here y is equal to 2 times f of x. So that's y is equal to 2 times 1 over x, which is f of x, which is 2 over x. If we've got y is f of a half x, and that's going to be y instead of x 1 over x, I now put 1 over half x, and if I'm dividing by fractions, that will become 2 over x. So we'll see that what we get is the same graph in this case. Okay, it's not always so, but in this particular case, they've ended up being the same graph. Okay, so this has been a video to show you how to do stretches of a cubic graph and a reciprocal graph. I hope you've understood, and just repeat, I put the GeoGebra Applet links in the notes of this video. Thank you very much for watching.